This is Ed Robinson of Kensington College, continuing our lessons on C#. We're talking today about file handling. We have some memory in a computer and we have a hard disk, and we can transfer from one to the other. And when we go from the memory into the hard disk, we call that the process of writing. And then when we're retrieving from the hard disk into the computer, into the memory indeed, that's called a read. And then the data can be displayed on a screen or something like that. So when we're doing a write, we're doing output from the memory to the hard disk. In this case, it could be some other device. But when we're doing input, we're doing a read into the computer memory. So let's see how we do those. So let's go ahead and create a text file, and then we'll write to the file, and then we'll later on read back the text from the file. So let's go ahead and straight do it. I'll explain a bit more about this in a moment, but basically we've got a stream writer object, and we're using that method to write to this text file, which is called ctext. Now you notice that's being escaped there. That's why we've got a double backslash. We could use the @ sign in here we just use a single. But anyway, that describes the path on the C drive. Now it may not work for you. It might give you a warning that permission to write is denied, in which case you could put a temp folder in there as well and write to that. But I've just made it on the C drive so that we can find it easily. So I'll go ahead and just run that, and nothing disastrous has happened, so it's likely that it succeeded. So I'll go and take a look in that folder to see if it's there. So yes, it is there. It's in my C drive, so I could double click on that and see what happens. Oh, that's opened up in Notepad, and you can see the text. It might be interesting to see how the text is actually stored on the disk. So let me take a look at that. If I go through now, you may not have this feature if you don't have full version, but I'm going to have a look at the file. So I'm going to open the file, which is called text, and it's on my hard disk on the C drive. And then I'll find the file, which is here, but I'm going to open it with the binary editor, open with, and with the binary editor. Well, you should find that I can actually do it from Notepad here as well somewhere. There it is. But I'm going to use the binary editor, so I'm going to open up that file. Now you may not be able to see that, but it says there 61, 62, 6F, etc., terminating with the famous 0D, 0A. Now this is all in hexadecimal, of course. I've explained this before, but hexadecimal, when we've got 0D, D means 13, A means 10. So that's correct. So 0D, this means line feed, carriage return line feed. A bit of a hangover, these things, from the old days of teletypes, I think, but what it does mean at the end of the day is that it is the end of the file. So we use 2 bytes to indicate the end of the text file. Let's take a look at these individual elements just while we're here. 6.1. Now what does 6.1 represent? Well, I'll just open up Notepad and show you. So I'll just use this for demonstration. If I've got 6.1, that's the hexadecimal. Now to work out the decimal value, we take 6 times 16. We always multiply that number by 16. 16 is a 96, and 1 makes 97. So that's the decimal equivalent of 61. This is 61 in hex, is represented by 97. What is hex? It's just a way of representing numbers in a simplified manner, shall we say, in a computer. So I could actually take a look and see what that 97 represents. Well, it better represent A, which is the first letter of about time. So I'll take a look at these, some ASCII codes. You can look these up on the net, and if you take a look down here, the ASCII symbol for 97, there you are. 97 is the letter A, fortunately, and that's got the hex symbol. It's done there for you, of 61. what about 0D0A? 0D13, there we are, is the carriage return. 0A, which is 10, which is the line feed, as promised. I think one of these is even the bell. That's definitely from an old teletype days, when it used to make a ding as it went to the end of the row, which is all pretty irrelevant these days. So we take a look at this code here and hold the mouse on there. It says provide static methods. You could go, of course, to on the help, but an interesting way is to go here to the definition of this. So if we take a look at the definition, and indeed if we click in here, it gives us a bit of help, which is rather nice. Provide static methods for the creation, copying, and so on of a file. And if we talk about the create static method down here somewhere, create a method, it's overloaded for, and so that's a static method for creating the file. And we could do the same thing here for the stream writer. If we just do a go to definition, that's interesting. It tells you what that stream implements the text writer for writing characters to stream. A stream, what's a stream? A stream is, you could think of as a temporary staging post for data when you create an object, and then it's ready to be put into a file, onto the disk, or it could be converted into XML and so on. So you'll see that often the stream you could think is a temporary object containing the data in memory, and then you can decide what to do with it. Notice the stream writer and the file both require the system input-output namespace. I'll just comment that out and see what happens if we don't have it. Well, you can see it's going to start complaining here, and this is an interesting feature actually. If you didn't know which namespace to utilize, then it says here show potential fixes. Isn't that nice? So we can click on that, and it says one of the fixes it's suggesting is using system input output. So I click on that, and you'll notice that that's been provided for me now in this case. Rather nice. So now I've got some text to read in the program to read in some text. Notice I've used the @ sign rather than escaping the text. That's just okay, just get rid of that. Okay, so now peek, what that will do is look at the next value in the file automatically for us, and it returns an integer actually, and so when the integer is it'll be -1 when nothing more is found. So that's a nice way of stopping it, and we're just reading out the text line by line. So if I try that, you'll find that should read back my text file. Let's talk now about reading and writing binary files. A binary file is when we store numbers as numbers, and we don't store the numbers as ASCII. So let's see how that works. We've got here, this time I've escaped the name of my file. I should really have an extension on there, not very nice, but okay. And I'm creating a new file and using this binary writer to write the file. So I've got 10 integers, 0 to 9, and I'm simply going to write all of those one by one to the. So let me just go straight ahead and try and run that, and so there are no calamities. So hopefully then we've got a binary file appearing. There it is there. So that's been produced. I need now to well, I'm going to take a look at that binary file just like I did before. So I'm going to go to File and then Open, and then File, and you remember we went to the my binary file. There it is there, and I'm going to open with and go to the binary editor. I must use the binary editor this time. It'd be a bit silly to use a text viewer like Notepad. So binary, there it is. Now that might be a little bit hard to see, but there it is. That's the first integer, 0, and they're consisting of 4 bytes each in hexadecimal, and they go all the way up to 9. If the next one, if we did 10, it would be 0. It would be 0A in that position, so it is hexadecimal. But the point is that numbers are written as numbers. So for example, if we were to go to our program and if this were a text file, then the number 1 would be written as the ASCII value for 1, whatever it is. It might be 62 or something or other, and then the number 2 might be 63, etc. So numbers would be, it's much more efficient to write numbers as numbers, and that's what a binary file is. A binary file is when we're writing numbers as numbers. So here we have the code for reading back our binary file in numbers. So we're looping through it, and we've got reading back 10 numbers from 0 to 0 to 10. 0, yeah, so 9 numbers, 10 numbers altogether, sorry, including the 0, including our increment operator. So that if we now run that, it should read back the numbers that we put in, which are the 0 to 9. Okay. Now you might not like the idea of, well, how do I know that there are 10 numbers altogether? So you might like to try this to make it more general. We're taking this base stream property of the binary reader, and it's finding its length, and then making sure it's an integer. This in fact will evaluate to 40. We've got 40 bytes, remember, 10 integers, 4 bytes long. So we need therefore to divide it by the size of the integer, which is the integer's got a size of 4. So 40 divided by 4, it gives you 10. So let's see if that works as well. So there, well, we've read the binaries back as well.